It's the week before Halloween here in Santa Barbara, California at the Seymour Duncan Factory. We're getting all scared and we're cranking out the scariest guitar tones and bass tones right here in our factory. Come join us. So first let's talk about what is a pickup. Well, a pickup is a device that literally picks up the vibrations of the string of an electric guitar or an electric bass, or in some cases an acoustic guitar, and it converts them from the mechanical energy of the string vibrations into an electrical current that then travels through the electronics of the guitar down into a cable and then into an amplifier where it's amplified and it comes out of the speaker in the form of a tone. Therefore, a pickup is a transducer, meaning it changes energy from one form to another, in this case from the mechanical energy of string vibrations into the electric energy that then goes into the amplifier. A speaker is also a transducer because it changes the electrical energy back into the mechanical energy of acoustic sound waves. So that's what a pickup is in technical terms. But in a guitar player's terms, what it really is it's the heart and soul of your instrument. It's the reason that your instrument sounds the way it sounds, whether it's a bright and chimey, glassy bell tone or a thick, dark, and chunky humbucker sound. That is all the essence of the pickup, adding to the sound of your instrument and making you sound like you. Behind me you'll see some of the different types of copper wire that we use to actually wrap or wind the pickups. One of the first things you'll notice is there's a lot of different color variation in the wire. Well, it's all copper, but you can't actually have copper touching copper in the coil. In essence, that would create one large turn of wire and you wouldn't really have a very good sounding pickup. So in order to prevent the copper from touching copper, you insulate the wire with a very thin layer of insulation. So for example, this dark chocolatey color, that's plain enamel. Plain enamel is the insulation that was found on the old Gibson patent applied for humbuckers, and it's actually what Leo Fender used on the very first Broadcaster pickups and some of the precursors to the Telecaster. When you get, for instance, a Seymour Duncan 59 model humbucker, it's wound with a plain enamel wire. Some of the old vintage Fenders use this bright gold stuff, which is called heavy form wire, and so we use it on a lot of our vintage Fender pickups like the SSL1 staggered for Stratocaster. The other thing that you'll notice, there's some numbers on here. They go from 40 to 41, 42, 43, 44. Those numbers refer to the diameter or the gauge of the wire. The way this number scale works is the higher the number, actually the thinner the wire. And if you're familiar with the gauge of speaker wire, for instance, it's actually the same number. So as you get to higher numbers, you get to thinner wire. By the time you get all the way up to number 44, you've got a wire that's about as thin as a human hair. Now here's how the wire gauge and the number of turns of wire works on a pickup. The more turns of wire, or the thinner the wire gauge, the higher the DC resistance of the pickup. The higher the DC resistance, the more output you're going to get out of the pickup and the stronger tone that you're going to get out of your amplifier. But you pay a price for that output, and the price is this. The more DC resistance, the less clarity and high-end detail that you get out of a pickup. So if you want a pickup that has lots of clear upper mids and treble and presence in the upper frequencies, generally speaking, you want a pickup with less turns of wire, or one with a thicker wire gauge on it. Or conversely, if you want something that's going to slam into the preamp of your amplifier really hard with a lot of output, then you're going to want one with lots of turns of wire or a very thin gauge of wire. This machine is called the pad printer. Anytime you see a logo or a name on a Seymour Duncan or Bassline's product, it's put on by this machine. Here, Esther behind me is using an epoxy-based ink that cures in about 24 hours, and once it's on pretty good. But basically anything that has a Seymour Duncan logo or a Bassline's logo, or sometimes on the Seth Lover pickup, you see there's a little stamp on the bottom plate. Our Woody pickups, it's all done on this machine here. Or as I like to put it, it doesn't say Seymour Duncan until this machine says it says Seymour Duncan. This part of the factory, we make single coil pickups, the kind that you would find on a Fender Stratocaster or Telecaster, Jazzmaster, Jaguar, Jazz Bass, P-Bass. They're fabricated bobbins that are made out of a couple materials, one of which is a vulcanized fiber. It's called Bobbin, and it's not too dissimilar from, say, a fiberboard, but it's impregnated with rubber. The bobbin is assembled between a bottom piece of flatwork and a top piece of flatwork, and they'll be held together in place by 6 Alnico rod pull pieces. These are sand-cast Alnico 5 pull pieces that'll be used in a single coil pickup. One of the things you'll notice is, see, they move around like that because there's no magnetism in them at this point. They are basically magnets awaiting to be magnetized. The other thing that you'll notice, if you look really carefully, is that there's a little chamfer or a little radius that's ground on one edge of the magnet. Leo Fender used to do that back in the day at Fender, and the reason he did it, it was easier to put the top piece of flatwork over the magnets when you had that little chamfer ground on the magnets. We don't actually have to have that chamfer in order to do it, but we have a very strong commitment to making pickups the way that they did back in Leo's day, and that's why we hand grind a chamfer on each individual magnetic pull piece. Here's a machine I bet Leo wishes he had. This is a pneumatic arbor press, and it's used to actually construct the fabricated bobbin that will eventually get the thousands of turns of wire wrapped around it. It very accurately makes them the same one after the other. So if you get a Seymour Duncan SSL2, for instance, or an APS2, or one of our tele pickups like an STL1, the vintage broadcaster pickup, the bobbins are all put together on this machine back here. One of the important operations in the manufacturing of the bobbin is to take the Bobbin flatwork and put these little metallic eyelets in them. Those eyelets will then have the magnet wire wrapped around them and make for a good solder connection. Up till now, we've been looking at vintage single coil bobbins which have been hand fabricated out of Bobbin and magnets. Humbucker bobbins, totally different story. These are injection molded out of high quality plastic like this one, which is made out of polycarbonate. We also use another type of plastic called butyrate for some of our vintage humbuckers. But regardless of whether it's an injection molded bobbin or it's a hand fabricated bobbin, it'll both serve the same purpose, which is it'll get wrapped thousands of times with copper wire, which will create the coil, which is one of the most important parts of the pickup. This is one of the most famous winding machines in current operation in the world. This is the famous Lisona Model 102 winder. This was used in Gibson's Kalamazoo, Michigan factory from the late 1940s up until the 1970s when we bought it. And we use it to wind our recreations of Gibson's patent applied for humbucker. I can see by looking at this sheet right here that it's actually winding the SH1 59 model. So here's the beauty of this. When you buy a Seymour Duncan 59 model humbucker, you're getting something that was wound on the actual machine that Gibson was using in their Kalamazoo factory in 1959 to wind the patent applied for humbuckers that were found on the 1959 Les Paul Bursts. It doesn't get any more authentic than that. This is an example of a winding machine very different from the Lisona. This is a very modern machine. It's called a Tanaka. They're made in Japan. We have about a dozen of them here. And this is all computer numerical controlled. Right now we're winding SH4 JB bobbins. So it's very consistent. We control the number of turns, the speed that it's wound, the number of turns of wire on each layer on the bobbin, and the tension that it's being wound at.